Okay, just walking through the steps of the tutorial for question 5. The problem right now of trying to evaluate the limit is that it's indeterminate because if you were to plug in 6 into the denominator, you would get out a 0. You have a divide by 0 error. And then, so what the walkthrough is trying to do is to get you through the textbook's definition of the quotient law. You can find out the limit of two different things that are being divided, an f of x and a g of x, if those limits exist and if the denominator is not equal to 0. If that's the case, if you can find those limits, then you can find the limit of the numerator and divide by the limit of the denominator. But the problem is the limit of the denominator does equal 0. So the quotient law does not apply. We say that f of x... Oh, okay, so this is confusing notation. They have f of x here up here, but I think they mean f of x as the original function, the 7x squared minus 13x. I mean, like the numerator is determinate. You can figure it out. But the original function is indeterminate. So they've reused f of x, and I don't think they should have. But these values, I think I already tested that before I started making these videos. I think the numerator and the denominator is 0. 6 times 6 times 7, that's 252. I'm just going to switch those signs. Okay, so both mine are 0, the numerator and the denominator. Okay, next part. Since the rational function has an indeterminate form of type 0 over 0 at x equals 6, we can find an equivalent expression for the function by factoring. So they want you to factor the numerator and factor the denominator. And as a reminder of those factoring steps, here I can do this on a whiteboard for you. When you're trying to factor quadratics, in the first term, actually, well, the first thing you want to do is see if you can divide anything out of all three coefficients. And there isn't anything in the numerator, but in the denominator, we can make it a little simpler. We can divide a 2 out of everything. Right? 2x squared minus 36. In the top, we have to leave it. Now, when you try to factor the numerator, you have to use the longer version of factoring because there's a number in front of the x squared. So what we have to do is we have to multiply 7 and negative 36, and then I'll show you what to do with that number. It makes negative 252. Our goal is to find two numbers that multiply to be negative 252, but add up to be negative 36. So it's a guess and check type thing. I mean, over time you might develop some intuition, but 4 and 63, there's no way we can add those together to make negative 36, even if one's negative, one's positive. Let's try to find some numbers that are closer. Oh, and actually here, that's where we can have some help. Look, the first term, they factored out a 6. Okay, so we know that 6 is going to be one of those factors. So I'm going to take, is that right? Yeah, that's right. 252. That works. Okay, so look, take that negative 252 and divide by 6. So if you have negative 42 and a positive 6, those are two numbers that multiply to be negative 52. Satisfies that first criteria. And those are two numbers that also add to be negative 36. So we're rewriting. It gave us that extra, the first factored piece, and that helped us skip some steps. Instead of guessing and checking all day long, we know what it's going to be. Okay, so when you rewrite, we're rewriting this expression, except instead of minus 36x, I'm putting minus 42x and plus 6x, and then minus 36. And that's all over to parentheses. Now here, x squared minus 36, we're going to write x minus 6 and x plus 6. I factored that pretty quickly. And the way I was able to do that is because this is no middle term. It's like 0x in the middle. So I had to think of two numbers that multiply to be negative 36, but add to be 0. Negative 6 and positive 6. So that's, actually, we're not quite done. That's the denominator. The denominator is factored. In the numerator, now you just have to factor by grouping to finish factoring. Put parentheses around the first two terms, the last two terms, and then divide out what's in common. So I can divide out a 7x from both of these. So it leaves me with 6 here. And then from these, I can divide out a 6 from both of them. And it's all over the same thing, so I'm just going to put quotes there. Same denominator. Okay, and then the last step in the numerator is there's two terms. You can factor out x minus 6 from both terms. So I've got x minus 6, and then when I factor out the x minus 6 from both terms, I have a 7x plus 6 left over. And then 2x minus 6, x plus 6. Okay, so that's what WebAssign's looking for in this step. The x minus 6 is the piece that's missing up here because they've already got the 7x plus 6. Oh, wait, x minus 6 and they're missing down here. Is that right? Yeah. Okay, we just got to make sure it's equivalent to what we have here. And so what they want you to say here is, what is this big fraction equal? What does this thing equal once we simplify? The whole point of factoring was so that we could find that the x minus 6 pieces cancel. So we have a 7x plus 6 in the numerator and a 2x plus 6 in the denominator. So here, I'm going to hit the fraction button. I got 7x plus 6 and 2x plus 6 in the denominator. Okay, step 3. Now they want you to try to reapply the quotient law for limits. So looking at the numerator, 7x plus 6, we can evaluate that one. That's not going to be 0 this time. Got 7 times 6 plus 6. That makes 48 for the numerator. And then if you plug in 6 in the denominator, now we don't have that divide by 0. 6 plus 6 makes 12. 12 times 2 makes 24. So the quotient law does apply. The limit exists. And so the last part, now that the limit exists, now you can find the limit at the top, limit at the bottom. You can just plug them in. Let's see. The top, we have 7 times 6 plus 6. The top is 48. And the bottom, 6 plus 6 is 12. 12 times 2 is 24. We have 2 for a limit. When you plug in 6 into the top, plug in 6 in the bottom, and then divide, we finally figured out the limit. We did it all WebAssign's way. Okay, so that's all. Those are the steps that you want to take when it's a rational expression and it's an indeterminate form. WebAssign just breaks it up in pieces.